Hi everyone, I'm Wenli. Today I'm gonna explain about multiple comparisons. It is called range test. Okay, when you use computer for ANOVA model and you get a result reject H naught null hypothesis, then you want to know which group population are different from others, right? The background of multiple comparison is not simple. So I will like to explain multiple comparison with some example. Okay, ANOVA is a technique used to test hypotheses about differences among several groups, say K groups. If they are differences among the groups, it is important to determine between which groups the difference exists that lead to the rejection of H naught, right? It means that to test for differences between each pair of K groups, then how many? K combination too many pairs. Hypothesis testing will be performed for K combination 2 pairs. There are many groups then. It is called multiple comparison or range test. Okay, same terminology. In other words, as a result of ANOVA, if the null hypothesis H0, all treatment effects are equal to 0, or mu1, mu2, mu k, all of them means are equal, the same thing, you know that. We need to determine which groups are different from each other. In this case, the null hypothesis is H0 mu I equal to mu j. Of course, I is not equal to j. And the test statistic gonna be what? Yi bar minus yj bar, right? You understand that? Why? Because this hypothesis is mu I minus mu j equal to 0, okay? A representative method of range test is Fisher's least significance difference, LSD. Fisher's LSD. I already told you R.A. Fisher, okay, he developed this ANOVA idea 100 years ago. Is that far ago? Uh, I think he's a genius. The LSD method is used to classify which of K populations are the same and which are different. In null hypothesis is rejected as result of ANOVA. It ultimately means that some of these hypotheses are rejected. So the result of ANOVA, okay, indicates rejection of null hypothesis. So it is necessary to find the pairs for which H0 is rejected. This one. Find the pairs for H0. This null hypothesis is rejected. Let the sample sizes obtained from ith and jth populations be denoted as Ni and j, and let the significance level be alpha. Fisher's LSD. It is original, but some other persons suggest other method. Fisher's LSD is defined as LSD is defined like this. Of course, you don't have to memorize this one because we will use computer. So, just I think you better know background of that kind of a multiple comparison, where the degrees of freedom of T here is that of MSE. Okay, what is it? MSE. We got MSE as what? Sigma square hat. So sigma hat is square root of MSE. Okay, you get a degrees of freedom from ANOVA table, and H0 mu I equal to mu j will be rejected when the test statistic is greater than this value, Fisher's LSD value. Then you reject H naught. Okay, let's see. In addition to Fisher's LSD, we will briefly introduce Schaffer, Tukey, and Duncan method. Schaffer method suggests his value. Instead of LSD, he suggested another criterion, which is V, square root F, sigma hat, and the square root this value, where F is the value of F with the degrees of freedom. This one, degrees of freedom, K minus 1, number of groups minus 1, and degrees of freedom of MSE, okay, sigma hat, at the significance level alpha, okay? And the Tukey, Duncan, suggested other different criterion, each of them like this. Okay, you can find the values, these values, Tukey, Duncan, even Schaffer, from the appendix of a statistics textbook, I think. But as mentioned earlier, you don't have to memorize or you don't have to these kind of things precisely. Let's see example, simple example. Schaffer and the Tukey method to investigate whether there are differences in pain relief duration based on the types of pain relievers A, B, C, D, E. 25 patients with a high fever of 38 degrees Celsius. Actually, I'm sorry, it is an error, a mistake. I think centigrade or more were administered pain relievers, and duration of pain relief was recorded as data. This data is the time of relief, okay, pain relief for A, B, C, D, and E, okay, 5 values, samples, data. The following table shows ANOVA table and results of multiple comparison using Schaffer and the Tukey method, like this. Okay, for ANOVA, this one, result. What is a p-value? 0.0015 p-value, okay? For what? H naught, alpha A, up to alpha E, all of them are equal. For this null hypothesis, p-value is here, so we reject H naught, okay? All of them are not equal. So we want to know which relievers, okay, are different from others. First, Schaffer method. Schaffer method gives us a result like this. B and C are different. B and D are different, okay? And D and E are different. It is symmetric from diagonal from here. So same values downstairs, okay? Let's see Tukey. Tukey gives us this kind of result output, and B and C has p-value here. P adjusted is not exact p-value, approximate p-value, something like that. B and D p-value 0.0018 and D and E p-value 0.0124. So the result is almost the same, but the p-values are a little different from between Tukey and the Schaffer method. But I cannot recommend which method is better. Okay, so this is necessary for you to conclude your ANOVA result, I think. Okay, this is it today. Thank you. Bye.